Okay. So let's do this. So here's a graph of a function. Consider the graph of f of x, and f of x looks like this thing. What we might be interested in doing is sketch the graph of f prime of x. All right. A blank canvas. What do we think? Any points of interest? Any times that we can absolutely tell what's going on? They would tend to be pretty important. Right? If f were describing, say, like how much money was in my bank account, I would definitely be interested in when was it at its max and when was it at its min. Or if we're talking about cost or population or anything else. Is there any information about the derivative at those points? Like, is the derivative especially important at those points? Yeah. Right. Those are times when it's flat. Okay? So you'll notice here at this point, the tangent line's flat. Also at this point, the tangent line is flat. So they're at the top of that hill and they're at the bottom of that hill. I know that those are going to correspond with zero slopes. So I immediately know a couple of points to kind of like lock in on f prime. What about this? When is the derivative positive, right? So it's really easy to tell when f is positive or negative, right? F is positive over here on this hump because the y values are positive, and f is negative down here because it's below the x-axis, right? These are negative y values, and these are positive y values. So what about f prime? When is f prime going to be above the x-axis? When am I going to have positive f prime values? What does f prime correspond to on a graph? It's telling me slope, right? So a positive f prime would mean a positive slope. So when is there a positive slope? 0 to 1, definitely, right? So over here, right, these are all positive slopes. The function's getting bigger over here. The function's increasing, and so all of these slopes are going to be positive. So I'm expecting positive here. Any other times? Or can we move on to negative? Yeah. So I think you mean here? Right, so this far right edge. So from when x is 3 to when x is 4. Okay. So this section, it's also positive here. So positive 0 to 1 and 3 to 4. What about negative? When's it negative? Yeah, the middle bits, right? So all of these have negative tangent line slopes, right? It's decreasing on this interval. And because the function is decreasing, that must mean that the rate of change is negative. So through here, it should be negative. So negative from 1 to 3. All of these should be parenthetical. I'm not including the endpoints. And remember, it's increasing, then it's decreasing, and then it's increasing again, right? So where it's increasing between 0 and 1 and between 3 and 4, it's going to be positive, f prime is going to be positive. Right? And where the function is decreasing, the slopes would be negative, so f prime is going to be negative. I'm going to move this up a little bit. That way you can see that I wrote negative here. Okay, and then it's 0 at these kind of points where it changes direction, where it's flat. Right? All right. So here's 0 to 1. What do you think about f prime there? Do you think f prime is getting bigger or smaller? Why?
It's getting positive and it's going to the red.
All right, so f is getting bigger, right? So, right, the f values are climbing. But that may not tell us anything about f prime. Right? It tells me that f prime is positive there. But what about the graph does f prime tell me again here?
It's the rate of change.
It's the rate of change. So geometrically, it's the tangent line slopes, right? So between 0 and 1, do you think the slope is bigger on the left side or bigger on the right side? Just between 0 and 1. Do you think the slopes are bigger closer to 0 or bigger closer to 1? So closer to 0, the slopes might look like what? Like this, right? And closer to 0, the slopes might look like that. So which of those two lines has the larger slope? The one on the left, right? So I'm expecting the values closer to 0 to be larger than the values closer to 1. I'm thinking that it's probably something like this. I'm just sketching. I'm expecting them to be going from bigger to smaller. And I know that at 1, it's going to be 0. And likewise, over at 3 to 4, well, we can just do them in sequence, right? We can do 1 to 3 next. All right. So it's coming down, and it's going to hit 0. And then is it going to bounce back up, or is it going to go underneath? It's going to go underneath, right? Because the function is going to start decreasing, and those are going to be negative slopes. Right. Where do you think that the derivative is most negative? Where is it going to be? Where's the derivative going to kind of like bottom out? Yeah, at 2. Why at 2? That's here, where I have that point. Why is that the most negative that it gets?
Because that's a 0 in your f of x, so that's where your slope would go flat.
The fact that it's a 0 in f of x doesn't mean very much, right? So for instance, let's have an aside here. So here are 4 graphs, and they're all a bunch of zeros, right? So here are 4 different graphs, and you'll notice that the derivative at these points, the 0 points, they're different in all of them. And some of them are big and positive, like this one. And some of them are negative, like this one. And some of them are small and positive, and some of them are kind of in between. Right? So the slope could be anything at that time. Right? So again, this will be fun. This is an excellent point to be made. So f relates to where, right? F prime doesn't care where. It relates to how steep. So here, right, where the function is doesn't tell me anything about how steep the function is. Right? So this is an important point for us to kind of keep in mind whenever we're trying to kind of relate f and f prime to one another. What f is doesn't tell me anything at all about f prime. But how fast f is changing, that tells me everything about f prime. So coming back here, up here, f is positive. It's the biggest that f ever gets. And down here, f is negative, and it's the smallest that it ever gets, or the most negative that it ever gets. So 2 very different places, but you'll notice that the slopes at those 2 different places are exactly the same. Both of the slopes are 0. So the slope at 2 is as kind of steep as the function ever gets. Right? Up here, it's less steep, then it's more steep, and then it's less steep again. So less steep is close to 0, more steep is further from 0, and less steep is close to 0 again. So I'm expecting something like this. Right? It's getting steeper and steeper and steeper, and it's always decreasing, so it's negative. And then it's getting less steep, but it's still decreasing. And then it's going to go back to 0 here. These points correspond. And then it's positive and not very steep, so that's like here. But it starts to get bigger. Okay? More steep, more steep. So bigger again. So the derivative might look something like this. I'm just sketching here. How far away from the x-axis f prime is, I might not know exactly. But I know that it'll be negative or positive. I know where it hits 0. I know whether f prime is increasing or decreasing. And so I want to reflect those in my picture as much as possible. Right? Is it getting steeper or flatter? Is it positive or negative, or is it 0? Right? Those are the questions that I'm thinking about if I just want to sketch a graph.